In this video, we will be looking at how to calculate the number of protons, neutrons, and electrons in an atom or ion based on the atomic number or atomic mass, and talk about how to symbolize an atom or ion, explain the difference between mass number and atomic mass, and also talk about what is an isotope. So the first thing we will talk about is the idea of the atomic number. The atomic number of an atom is equal to the number of protons in the atom. And if we look at our periodic table, or the periodic table that was handed out in class, the atomic number is the number listed in the upper left-hand corner. So if you need to, you may want to pause the video and take your periodic table out. The number in the upper left-hand corner is the atomic number, and it's going to tell us the number of protons in an atom. It can be symbolized with the letter Z. So for example, we may see something like this. Z is equal to 6. This Z tells us that the atomic number for that particular atom is 6. If we were to look on our periodic table then, we could identify that atom as being carbon. And what that tells us is that every carbon atom is going to contain 6 protons in the nucleus. The mass number of an atom is equal to the sum of the number of protons and the number of neutrons. If we look at this word sum, mathematically, that word sum implies addition. So the mass number for an atom is really going to be equal to the number of protons plus the number of neutrons. Okay, it is symbolized with the letter A. So for example, we may see something like this, where it says A is equal to 12. This would tell us that this 12 represents the mass number. And again, the mass number is equal to the number of protons plus the number of neutrons. Okay, that is where a majority of the mass of the atom comes from. Remember, protons and neutrons are found in the nucleus, and so that is where it gets the name mass number. When we symbolize atoms then, there is a general format that we use, and the general format looks like this. Okay, A, superscript of A, subscript of Z, followed by X. Where A is equal to the mass number, remember we just established that the mass number is also equal to the number of protons plus the number of neutrons. And where Z, that bottom number, is equal to the atomic number. And remember, the atomic number is equal to the number of protons. X here is going to represent the symbol of the element then. Remember, the symbol of the element can be found on the periodic table and is not something that ever needs to be memorized. It's important to remember when we talk about atoms, remember atoms are electrically neutral. So in terms of the number of electrons is going to be equal to the number of protons in a neutral atom. Okay, if we do not see a charge, then we assume we have a neutral atom. When the protons do not equal the electrons, we now have an ion. Okay, and remember, ions contain positive or negative charges, and in that case, we would add a charge to our ion, or to our symbol. Okay, so we're going to take a look at a few examples of how we would symbolize atoms and then the information we could gather from that symbol. Okay, so in our first example, we're going to start with this symbol. We have Mg, 12, and 24. Okay, if we think back to our last slide, our general formula looks like this. Okay, the Z, this bottom number here, is my atomic number, A is my mass number, X is the element symbol. If I were given a symbol like this, I should be able to determine then the number of protons, the number of neutrons, and the number of electrons in this atom. Okay, the bottom number here, remember, represents the atomic number. The atomic number always tells us the number of protons. The other thing we should note is that the atomic number and the element symbol should always match. So for example, if I were to look on my periodic table and I locate magnesium, I should be able to see that magnesium has an atomic number of 12. Okay, we can't have magnesium symbol with, let's say, an atomic number of 13, because with an atomic number of 13, we no longer are dealing with magnesium, but rather we are dealing with aluminum. So the atomic number and the element symbol should always match. Okay, so from this information then, the number of protons is always going to be equal to this bottom number, and in this case, there are 12. A magnesium atom will always contain 12 protons in the nucleus. To find the number of neutrons then, remember this mass number up here is equal to the number of protons plus the number of neutrons. Well, if I know that there are 12 protons and I have a total mass number of 24, I could take 24 minus 12, which in this case gives me the 12 neutrons. So this top number and the bottom number, subtracted from one another, will always give us the neutrons. Okay, the last thing then has to do with the electrons. Again, if we have a neutral atom, the positive and the negative charges have to cancel each other out. So in this case, we have no charge indicated here, so we would assume that we have a neutral atom, and therefore the number of electrons are going to be equal to 12. Okay, let's look at another example, one in which we may see a charge. So let's say I have a fluorine ion. Okay, the atomic number is 9. My mass number is 19. Once again, from this example, I should be able to determine the number of protons, the number of neutrons, and the number of electrons. Okay, once again, we focus on the bottom number for the number of protons. The top minus the bottom number is going to give me the number of neutrons. And now for this one, I'm going to go in and add a charge of -1. Okay, if I see this charge of -1 up here, that tells me that my atom is not neutral, but rather I'm dealing with an ion. And remember, atoms become ions by gaining or losing electrons. So the number of electrons in this example is going to be different than the number of protons. Okay, because the charge is -1, atoms become negatively charged by gaining electrons. So this means I'm going to add 1 electron to the number of protons. So I have 9 protons. If I add 1 to that, I'm going to end up with 10 electrons. Okay, so a negative charge means the number of protons is greater than the number of electrons. If we look at one more example, here I'm going to deal with calcium. Okay, 20, 41 with a +2 charge. Once again, I want to be able to determine the number of protons, the number of neutrons, let's change my color, and the number of electrons. Okay, bottom number here tells me the number of protons, 20. Top minus the bottom number gives me the number of neutrons, which would be 21. Okay, once again, I'm dealing with a charge, +2. In order for an ion to become positively 2 charged, it has to lose 2 electrons. Okay, well, in a neutral atom, I would have 20 electrons. If I've lost 2 of them, I end up with 18 electrons. And so a way to kind of think of this or to help you out is when looking at a charge, you're going to do the opposite of the charge to determine the number of electrons. So for example, a -1 charge means that instead of subtracting 1, I'm going to add 1 to the number of protons in order to determine the number of electrons. A +2 charge on the calcium means instead of adding 2, I'm going to subtract 2 from the number of protons to determine the number of electrons. So again, anytime you're given these atom symbols, you should be able to determine the number of protons, number of neutrons, and number of electrons contained within that atom or ion. Okay, last 2 things we need to talk about. First of all, this idea of an isotope. An isotope, or isotopes, I should say, are atoms that contain the same number of protons but have a different number of neutrons. Okay, so the key phrase being the same number of protons but different number of neutrons. Going back to what we talked about in terms of the atomic number and mass number, in other words, isotopes are atoms with the same atomic number but different mass numbers. Okay, so an example of 2 isotopes would be as follows. I could take calcium and symbolize it like so. Okay, both of these isotopes, or both of these examples, I have calcium with an atomic number of 20, because 20 protons are the only number of protons that can be in a calcium nucleus. Okay, but I could have calcium that contains 40, a mass number of 40, or a mass number of 41. If I were to determine the number of neutrons in each of these, in my first example, the number of neutrons would equal 20. In my second example, the number of neutrons would equal 21. So this right here is an example of two isotopes. Okay? They contain the same number of protons, but differing numbers of neutrons. It is important to note that in order to be considered an isotope, the atoms have to be the same. So for example, I could not have these two atoms, calcium and potassium, be considered isotopes. Okay, they are completely different atoms, therefore they're not considered isotopes because they do not contain the same number of protons. Okay, the last thing we're going to talk about is this idea of the atomic mass. The atomic mass of a substance is equal to the average mass number of all of the possible isotopes weighted by abundance. So if you were to look on your periodic table, okay, if this was my element symbol box, we know that the atomic number is found in the upper left-hand corner. The mass number, or I'm sorry, the atomic mass then would be found in the upper right-hand corner. And if you're not sure, double check your periodic table and look at that key, and it will tell you that that's the atomic mass, or it may call it the atomic weight. Okay, so that's an average of all of the possible isotopes that exist for a particular atom, and the abundance, or the percentage of each that naturally occurs, is taken into consideration. So an example of this is there are 3 isotopes of carbon. There's carbon-12, carbon-13, and carbon-14. These numbers here represent all of the different mass numbers. Okay, there's the most of carbon-12, but the existence of heavier isotopes brings the average atomic mass up to 1201. So if you were to look on the periodic table for carbon, the atomic mass would be, or atomic weight would be equal to 12.01. Okay, we cannot have 0.01 of a neutron, but this number is a decimal because of the fact that it's averaging all of the possible isotopes, also taking into consideration the abundance. Okay, we will talk much more about atomic mass later in the year and use it for various calculations.